Hello T-Squared Tutoring, it's James. Know it's been a while since I last made a video, but I got sick when I originally made the one that got posted earlier today. Got sick, and then I just forgot about it because got busy with school. But I'm back with the videos. I know a lot of you missed it, especially two people who comment every video, and they know who they are, but enough yapping from me. Let's get to the point. So, what do we have today? Listen to me. Basically, we're just going to have to, 1, find the period of tangent functions, and 2, graph said tangent functions. Now, I only have to do 4, luckily, but before we do that, I think it's important to start and see what does the original tangent function look like. So, have this little squiggly thing here. See, I'm kind of drawing along it. Goes from 0, pi over 2. Sorry, that's not pi over 2. Double sorry, because my thing's freezing right now. My Desmos is freezing. That was weird. Anyway, you see how it repeats every pi? There's another one of these. And if you're wondering, they don't touch. They just repeat. So, that's what the original tangent looks like. And the period is pi because, well, it repeats 0, pi, to 2 pi. You know where I'm getting at. So, what does it specifically ask for this problem then? So, 12, what you want to do, well first, sorry, I should have specified the period. So we know that the original function is going to go something like doop doop doop. And that's what a tangent looks like normally. The period is still that man, I'm really at a loss for words at this problem. But on a serious note, you see how that works and how the period, it repeats itself every pi. So, when you have this plus pi over 2, or something like this, the period is the same. The only difference is you just shift it over. So, instead of this being at 0, you need to take our original. Actually, I'm going to use blue for original tangent here. Or tangent theta, sorry. And then black's going to be the new function, just so you can visualize it. I'll probably get rid of it in a moment, but alright, so we're going to take our original. Going to put points here, because it repeats. Here. So we're going to have something like that. Now when you have plus pi over 2, you just need to shift it over pi over 2. So you have 0. If you add pi over 2 to 0, you just get pi over 2. Add pi over 2 to pi, we'll get 3 pi over 2. And then if you add it once more, then you're going to get a point here, I think. Wait a minute, hold on. Give me a moment, please. Pi over 2. No, I'm incorrect. Forgive me. And the next point would be somewhere over here in this area, but we don't have that, so I'm just only going to graph the 2, which will be here, 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 here. Now, nothing happened to the period, and to find if something does happen to the period, you look at your variable theta. Since that's unharmed, the period is just going to be r. Not r. This isn't a circle. The period will be pi. So that's that for that one. Now let's get to 16. Now before we were using radians, which was in essence the pi over 2, whatever. But what it may ask you is degrees. Now what are degrees? Good question. They're Here's a way to convert them between it. I personally prefer to just have everything in radians because that's what I've been using for most of my life involving tangents and stuff. So I'm going to teach you how to convert. So if you have pi is equal to 180 degrees, 2 pi equal to 360 degrees, and they both equal 0. Cool. What does this mean? So, if you know what that's equal to, if you know that pi, specifically, I'm going to remove that because we don't need it at the exact moment. But if we know that pi is equal to 180 degrees, and we know that 210 equals 180 60s plus 60, that means we can also find pi over 6 equals 30, because if you divide both sides by 6, so you have a pi plus pi over 6. And that in total will give you, you can rewrite it in terms of radians, so y equals tangent theta plus 7 pi over 6. Once again, how does this help? Technically speaking for this one, it doesn't help at all. But you may have a problem where you need to convert units, and I just taught you how to convert units. But regardless, let me get back on track, if you would allow me to. So I'm going to use blue again for our tangent. So original function goes like this, this, do, something like that. When you're shifting it over 210 degrees, that's going to land you right around here. So because if you look at it's in the middle of 180 and 240, midpoint is 210. If you want to count 1, 2, 3, 4, 5, 6, 7. So you have to shift everything over by 7. Let me just redraw this if you don't mind. Now we need to shift this one over by 7, assuming we have room. 1, 2, 3. 1, 2, 3, 4, 5, 6. And then this would be at 400. Wait, 400. Hold on. 390. I don't know why I said 400. Sorry. And this would be here. Something like this. Let me remove these dots. And I'm going to remove the tangent graph since you saw what it looks like before. This was just for visualization. And I'm going to specify that here it's 390 degrees. So we know, or that your teacher knows that you know what you're doing. Anywho, you got that? But you also need the period for this section as well. Period is still just pi, because you didn't actually change anything with the theta itself. It's just theta, so it's going to repeat every pi. Or every 180 degrees if you prefer that. So, next problem, number 20. So you have tangent of 2 theta plus 300. And we finally have something different in terms of period of this. Because you have the original theta multiplied by 2, your period is going to be every pi over 2. Basically meaning it's going to happen twice as much as it did beforehand. So instead of repeating every 180 value, it will be every 90 degrees you'll see a new So I'm going to use blue again, just to show the base of tangent 2 theta. I have one at 90, so like 0, 90, 180. Whoa, slow down. 90, no, I take it back. 180, 270, 360. So it's gonna have a little swoop, is what we're gonna call it. Alright. Also forgive my dad for coming in. I forgot to tell him. Maybe that caught in the video, maybe it didn't, but my apologies. Yeah. So this is the base function. What we need to do is we need to move it over 300 degrees. So, once again, it's going to look pretty darn similar to the one we did last time. But, it's going to look similar in terms of I need to add more space because I wrote big. Forgive me, I'm just double checking my answers because I don't trust myself. Yeah, okay. The graph looks fine. So, let me just confirm that I didn't screw you guys up. Just give me a moment, please. Till then, I'll just yap about random nonsense. I had a bowl of cereal today for breakfast. It was pretty good. I enjoyed it. Okay, so now that I actually confirmed it, I made a little mistake. So feel free to point and laugh about now, but I made a mistake. The shape of this is going to look a little different. The points are right, don't worry. Never get my points wrong. Let me rewrite said points. But instead of looking straight like this, it's going to look more of this. It's going to have a little, like a little curve, like that. A little more sass to it, dare I say. I don't know what I'm talking about. Anyway. Hopefully it makes sense. Now that I've corrected. So we just need to shift it over 300 degrees to the right. So if we had one, it didn't mark. If we had a 1 point at 0, that needs to move over to 300. I'm going to make another point here, because we had another point at 90, but it's outside. I'm going to mark it as 390. I'm going to go draw that same shape. And forgive me if it overlaps a little, but it might. So yeah, we have the period and we have our graph. So we're good. Now, my unnamed student decided to give me a really hard one. Not sure if I made him angry earlier today, but one that certainly increases the difficulty. But I believe in you all, so I think we can get this one done too. So, what is the period here? Now, if we're looking at our original theta, it's 1/3. It's 1/3 times theta. So when you had it multiplied by something like 2, it happens twice as likely. So since you're dividing by 3, it's going to be 3 times. It's going to be a third. It's going to happen a third of the time instead of all the time. You know what I mean? You know what I mean. Probably. I'm just gonna assume you know what I mean. It's more convenient that way. Anyway. So, we know this is gonna make our period 1/3. Or pi over 3, I should say, sorry. Wait, not pi over 3. It's gonna occur every 3 pi. Because of the division. Or at least, yeah, 3 pi. So, that's our period, I believe. Then we need to add this 7 pi over 6. That's not good. This is thick. Finally, we need to shift the graph up by 1. So what is this going to look like? So do we have pi over 4? Anything in terms of pi over 4? No, we don't. That's okay. So, 0, we're going to have, because of the plus 1, it's not going to be at 0, 0. It's all going to be a little bit up. I believe it's, looking calculated, it's about 1.5 specifically, but just do like this. I'm going to have it repeat like that a couple times. Sorry, no, I take that back. It's not going to actually occur there. First point we're going to look at. What a shame. The first x-intercept we're going to look at is 7 pi over 4. What is that? Hold on. Please. It's going to be right in between these two, 7 pi over 4. Because if you converted it, this would be 6 pi over 4. And that would be 8 pi over 4. So it's going to be right smack dab in the middle. I'm going to have a point there. And I'm going to have a little point. Why? I take it back. It's not, the graph isn't, the plus 1 doesn't shift the graph. They should have specified. I mean, I was incorrect on that is what I'm trying to say. Goodness gracious. But they will still intersect. It will just affect where exactly it intersects the graph at. But anyways, I'm going to have one at 7 pi. Going to have another one. And it's going to repeat every 11 pi over 4, actually. I messed you guys up again. That's on me. Sorry. Every 11 pi 4 is when this graph is going to show up again. So that's going to give you 19. 19 pi over 4. That's when the next period, our next point is. Should be a little, which I believe should be right here. No. Okay, it actually happens right when the graph cuts off, right here. I have a little. This graph is still gonna look pretty normal compared to the other ones. It's gonna look a little like this. Look more like. No, not a line. Definitely not a line. It's gonna look like that. And then something like that. That's what 30 is gonna look like. Believe that's the last one. Yeah, that's the last one I was requested to do. So hopefully this helped a little. Sorry if a few things were a little clear or vague. It's been a really long time since I've had to graph these functions, but hopefully it should get you a better grade than before a tutoring lesson. So, yeah. Have a nice day, everyone.